Going back to P1 method, this is the specific heat capacity. Specific heat capacity, this is the unit is joules over kilograms times degrees Celsius. We see this will be important a little bit later. So I have three different containers. The first one is made of copper, the second one is made of aluminium, and the third one is made of water. Now if we look at the numbers of the containers, we see that the number for water, for example, is 40 to 100. The number for aluminum is 913, and the number for copper is 330. That means that copper, having the lowest number, needs the least amount of heat to warm up, and also needs the least amount of heat to be given out when it cools off. So copper heats up the fastest, copper cools off the fastest. It has a low specific heat capacity. So this number 330, we consider it as a low specific heat capacity. That means it does not retain heat well. Heat goes in fast and goes out fast. If I'm looking at the water in comparison, we see that the difference between 40 to 330 is more, almost 15 times. So that means water needs 15 times more heat to warm up to the same temperature the copper does. It's a huge difference. So the water will have actually a very high, I could have put here, very high specific heat capacity. That means it retains heat very, very well. It also needs a lot of heat to warm up. So water heats up the slowest, but it also cools off the slowest. So the one that heats up the fastest, the one that gets the heat in the fastest one will be the one that loses the heat fastest. The one that gets the heat in the slowest one is going to be the one that loses the heat the slowest. So specific heat capacity happens when a substance is a solid or a liquid or a gas. So for example, this copper, when is a solid, that means anything until its copper starts to melt, we always use the same number as the specific heat capacity. As if we look at aluminium in between, now aluminium, we see it has 3 times higher specific heat capacity than copper, but almost 5 times lower than water. So it doesn't heat up as fast as copper, but it doesn't heat up as slow as water either. An example from our everyday lives. So for example, you go to the beach, because sand has a lower specific heat capacity than water. During the day, when the sun is up, it gives off a lot of energy. Sand gets hotter than water faster because it has a lower specific heat capacity. And we see here the one that has, like, comparison with copper, the one that has a low specific capacity heats up the fastest. So sand gets hotter than the water faster, but at night also sand will get cooler than water faster. That means water doesn't heat up that much during the day, but doesn't cool off that much during the night, which is a good thing. Now for the calculations, this is only for triple. We have the formula Q as heat equals mass times C for specific heat capacity times a change in temperature, or delta T, or this letter is a Greek letter called theta. So all you have to do is plug in the numbers. All you need to recognize is the mass. It will have grams or kilograms. That C will always have probably this value, kilojoules per kilogram degrees Celsius, or sometimes it could be joules per gram without the K in front, degrees Celsius, and theta, or the change in temperature, is always given in degrees Celsius. The last thing we have to add here, for example, you have a copper pan and you're heating up water in the copper pan. Now copper pan has a low specific heat capacity. It will get hotter much faster than water, which has a high specific heat capacity. That's why, like, the pan gets hot very fast, but water needs a good amount of time to start boiling. So this is specific heat capacity. Hope it helps. Thank you.